Okay, we're live. Today was a crazy day, right? So let's get to it. So we left off and we, god damn it. There we are. Because I can hear myself over here fine. Last thing we did, we had a bug here that we wanted to fix. So just gonna put this up here and we can check it later. And we're gonna fix this. I'm gonna remove all of this. Pretty sure that allowance was okay. It's not allowances. I still haven't read any of the other ERC20 code, so I may make a few mistakes, but we'll try to fix them after. Transfer. We check that the message sender's balance is greater than or equal to the amount that they want to transfer. So this would be insufficient balance, right? Then we subtract from message sender. We add to this address and we emit. And this should all be good. And I'm pretty sure that, yes, we need this. One thing that I want to test is if I have balance of here and I have balance of here and the optimizer on, if this is enough for Sol-C to recognize that. So optimize 1 and app debug. Yeah, I want to try this out. So we want to test the transfer. We go into the transfer, don't we? Xcode size, gas, call. Okay, so now we're inside. Balance. We're inside transfer. And we do color, right? Here it is. What is that? Let's see if this is correct. Okay, here it is. We S-load the balance of message sender. And we check if it's greater. And yeah, here it is again, a second S-load for the balance of message sender. So we do not want this, right? That's the first thing that we're gonna fix. And looks like, unless I am actually doing something very wrong, that Sol-C does not optimize this. So, what? So we want to say that the balance of the message sender is this, right? And let's see if this is correct. But here, the mistake that I made yesterday is that I was updating a local variable, and now I want to do this. This looks good. So we put the balance of message sender on its own local variable in memory. We check that it is greater than the amount. And then we store the difference, so balance minus amount, and we add it to the, the recipient. Do we want to put recipient? I like small variables, but we'll see. And let's test this. So transfer, we're gonna do the same. I don't know if they've added any kind of breakpoints. Where am I? Oh, did I go over? I don't know if they added any kind of breakpoints to this. So in the meantime, we're gonna have to do it manually, but that's okay. Here we have the S load, so we S load the balance of message sender, which is this. It should be the total supply, right? And we store it in memory. And we store it here. So one S load, one S store, and it should be the same below. We need to load it. We need to load the balance of the recipient of the two adders, which is here. So S load, and they have 0. And you know, this, I'm pretty sure that whenever this is jumping, it's the overflow check from Solidity 8. Greater than 0, right? Yeah, I'm pretty sure that it is. And a store. Perfect. Like, that all looks extremely well. The log3 for the event. And we're good. And, you know, it ends. Excellent. So we had transfer. Let's do transfer from. We're gonna need an event approval. I honestly don't remember. I think it's approval. And this is not from to, but either way, we can fix it later. We already have the allowance. So we need a function called approve. We need to approve a spender and an amount. And this is the same, returns a boolean, right? I mean, let's do it. And this should be as simple as allowance message sender. So whoever sends this, I am allowing this address to spend this much, right? We emit the approval event. So message sender spender amount, and we return true. That looks correct to me. We're gonna do some tests after, but let's say this is die, so I approve whatever the Uniswap router, right? So I say approve the router on infinite. and then allowance. Yeah, this is good. So let's do the transfer from, and then maybe we can check if we don't want to duplicate some of this code. If it is better to keep this, if we want to have transfer, do a call to transfer from, or if we want to like duplicate it, transfer from, and this is I don't know, amount. This is also external, and it returns a bool. So the first part should be the same, right? First, we need to check that the from, let's do it from scratch. We need to check two things. We need to check that whoever's calling this, the message sender that is calling transfer from, is authorized on this. So from is going to be here, message sender is going to be here. This is the part that I mess up extremely often. Although we do need to check the balance of message sender. So let's just start, and we'll fix it when we need to. The balance of the from is going to be greater than or equal to the amount, otherwise insufficient balance. And now we need to check if the allowance of the from to the message sender is greater than or equal to the amount that we want to send. I mean, we can require this as well. There's probably a lot of ways to do this, so not enough allowance. And we're gonna do the golfing as well here. So if we're allowed, we reduce the balance of the from we increase the balance of the to by the amount. And all of this we're gonna need to put them in memory. The allowance is gonna be minus equal to the amount as well. So we reduce the allowance, and then there's infinite allowance, but we'll see about that later. We reduce the allowance, we reduce the balance of the from, the balance of the to, we emit and return. That looks correct, although like I said on Twitter, this is like my second time live streaming and my brain is seriously working at 5% capacity. And yeah, as you can see, there's a lot of duplicate code, so maybe it will make sense. But let's just do a test. first. And we're gonna need a couple of users, so contract user, and they're gonna have a token and that's it. Do approve. And that, say token spender, we always called it a 2, so let's leave it at that, and the amount. And the user calls cxx.approve to an amount. That looks, well, and we return this, right? Let's do the same, we do transfer. And let's do the transfer from. So let's create a couple of users. User 1, user 2. We have 2 users. So let's transfer. I mean, we're gonna test a lot of things here, but to user 1, let's transfer 1 ether, and let's assert that balance of one, two. What am I missing? Oh, idiot. Cool. So instead of debug, I want to test this again. And does this work? Match. The test. Yeah, matching the rejects. So from, I think it's like that. Test transfer from. Okay, so far so good. Now we do. The user 1 is going to do an approve. On the token, and it's gonna approve the second user to spend half an ETH, right? Then user 2 is gonna do a transfer from with this token from user 1. I actually should no, to itself. .5 Ether. And if this works, then, well, we can check for a whole bunch of things. The first one, we want to check that the allowance from the address user 1 and the address user 2 is 0.5 Ether. After the transfer from, the allowance is going to be 0. And the balance of both 1 and 2 is going to be 0.5. Let's see. We do the setup and then begins transfer from. So we transfer from a user this is this first one. Where is this transfer from? We assert that the balance of user 1 is 1 Ether. Then we do the approve. And this is good, approving on half an Ether. Then they both have half an Ether and the allowance is 0. And this looks correct. Let's do another quick one. Let's do a test fail transfer from. Let's do everything is the same. We approve for 0.5 Ether. Sorry, yeah. We approve for 0.5 Ether and then we try to transfer 0.6. And that should fail. Bail. And in this case, this is correct, right? It's been a while since I've used DApp. My remembering of this is that it should pass because it's a failing test and it's failing. We'll have to go over that later. But if I'm not mistaken, that should be it. If there is any bugs, I'll have to check in a bit. Does changing the allowance change this? I think, does it? I have no idea. It may, and we may need to lower the allowance. But let's do this. So this is called twice. We should do a variable here. allowance is this. We require that the allowance is greater than the amount. We decrease it here. Okay. Allowed. And this one as well, right? This. And we subtract it here. Let's see if our tests are working. Test fail. Oh. Was it test fail? Yes. God, I love remembering this stuff. Is there anything else here? There's probably nicer ways to do this. We're missing mint and burn. We're missing, we want to check external public. We want to check this. How long have we been going for? 30 minutes. Let's do 10 more minutes. I want to go over this one. Just gonna copy test into debug. Have VI inside code. We don't want this, and we want this. Test transfer from. Let's do it. First is a transfer, then it's the balance off. Then it's the approve. Allowance. I want to go inside transfer from finally, please. And we're inside the token. We are looking. What do you mean source not found? Okay. Balance off. We should s-load it. Has 1. That's correct. 1 to the 18th. Checks that the balance is greater than the amount. Reads the allowance as well. That should be another s-load. Here it is, 2. And if it lets it do it, it stores the new allowance. That looks okay. Balance up, that should not require another S load, just an S store. Here it is. And they should be both, right? Because we're reading how much it had here, 0. And we're gonna add the amount. See, here, add, you see? There's 0 and there's the 0.5. Add, nice and easy, S store. And then a transfer and then returns true. God, I hope there's not a bug in this one. Name, symbol, decimals, constant total supply, balance of allowance, transfer, approve or approval. I don't remember. You can approve, you can transfer, turns bool, and you can transfer from. Is this like a 100% compliant ERC20? I'm 99% sure that it is. We'll see. So what are we missing? Optimized versus non-optimized. Memoizing variables, how many S loads, external, always cheaper. So this is what I want to test. Because, and assuming everything works, this is like way too much, but still. If we call transfer, and it is a public function which calls, sorry, it is an external function which calls transfer from, which would be a public function. How much does that change versus, you know, having this and this? That is 1, which should be good. The over-under flows, the automatic, are they good? Can we use a library? We can check mint and burn, they're easy, and you know, we need to make this not constant, which we should fix this as well. But for now, I'm gonna go. We're gonna continue this later. Thank you, everybody.